afternoon, everyone. Everyone here and also those who are attending online. I'd firstly like to start off by acknowledging the traditional owners on the land in which we meet today. Apologies if I mispronounce this one, but the Kumbamari peoples. I'd also like to thank Uncle John for doing his welcome to country. Secondly, I'd like to just pay thanks to Actium, the Actium team and Bond University for putting on this great event. I think there's lots of accelerated change that's happening in the tech space and within law and how that relates to law. And I think it's really good that we've got like-minded people coming together within the profession as well as the technical experts who can talk on the topic. So we'll kick things off. Introductions. So what I'm going to be talking about today is essentially an overview on what robotic process automation and artificial intelligence are, as well as getting stuck into some legal industry-specific use cases. And then we'll get into some demonstrations on what does actually RPA look like when it's running. And we've already seen some examples of artificial intelligence in motion, and I'll show some others as well. Defining RPA and AI. So robotic process automation, the definition you see here, this is from Gartner. This is from Gartner. And the definition here, it can be interpreted in almost different ways. I've spoken with some industry professionals, and they also somewhat question what actually is robotic process automation. I think from a CA Labs perspective, I think the key thing to call out here is the orchestration of UI interactions. So it's automating that UI interactions component. The second thing is artificial intelligence. So again, this is a definition from Gartner, and it's applying advanced analysis, logic-based techniques, including machine learning to interpret and provide support and automate things. So that's another term from Gartner there, and it can be a little bit hard to conceptualize what it means. It could mean it includes RPA, it could mean it includes deep learning, machine learning. And I had a chat with Dr. Alan Thompson before, and he agreed with me. Sometimes these terms can just get messy, and it's best not to get bogged into the buzzwords. So from a Cognitive Automation Labs perspective, how we like to define and communicate these two technologies together is that they are separate and perform specific things with relation to automating knowledge work for an organization. As you can see here, how we view robotic process automation is it's essentially the arms and legs, or the execution of automating knowledge work. And it's specifically, on its own, can only handle non-intelligent tasks. And this comes back to what he mentioned earlier in his kickoff speech, that there's a lot of robots or AI out there that aren't actually that intelligent, and it's because they're based off rule-based decision logic. That's the non-intelligent component I'm talking about. Artificial intelligence, the way we like to communicate and come together and define that term is it's essentially the brain component of automating knowledge work. And the brain component where there's inferential decision making relating to anything that requires vision, so maybe you're looking at a document, or language, you need to read the document and summarize it perhaps, and then thinking and learning. So you've never seen this document before, but you need to figure out how to do whatever it is you need to do to complete your business process. So that's the artificial intelligence component. And you can see there that the AI part is the intelligent part, it's intelligence, the brain, and robotic process automation is the execution component. Time. So in terms of, we spoke about RPAs being the arms and legs or the execution part of automating knowledge work. So there's other ways that you can automate knowledge work or conduct the execution of that automation. At the base here, there's the infrastructure. So cloud computing, that's a big area of mine. A lot of your solutions will sit on cloud infrastructure, you sit on-prem, but that's something you automate, and as well as applications. So maybe you've got a business process, let's say you're using Excel to manage your customers, and you think, I need to automate some of this process, so I'm going to implement a CRM system, which will implement a lot of the business process for you. So that's another part of automation. And then there's the application programming interface. Now, when you want two applications to talk together, this is what you use. You use the application programming interfaces, so then they connect together, and then they can automate that flow for you. Now, these two parts here, applications and APIs, is a more traditional approach to automating workflows, automating knowledge work. If you look on the left-hand side, a lot of these new tools are coming out so that business users who actually do the business process on a day-to-day basis can perform or bring together what we would say a non-production ready solution, but an automated solution they can test, they can run, and they can hand that over to a more technically competent individual to optimize it so it's ready to deploy to a production environment. If you've heard of things like Zapier, has anyone ever heard of Zapier? Yeah? Or Power Automate as well, that's another one. So you can view those as being those connector or workflow automation scenarios. And they essentially use application programming interfaces, they build on top of them, except they present it in a way that it's just connecting things and entering fields. So it's business friendly. Now, robotic process automation, where it differs to these other execution technology approaches, is that there's that UI interaction component. So like I said at the start, it's UI interaction. All of these approaches here, you need to interact using scripts or backend, but the robotic process automation component has an agent component to it that can interact with a UI, log in using or like an agent username password, and then perform things. You can see it conducting those activities. So you'll see that in the demo. Now, the misconception with AI projects. There's a misconception that AI projects, if you're going to look to automate some knowledge work within your business to get some efficiencies, and then put your people into more value-adding tasks, like talking to customers, there's a misconception that AI projects and that use cases that require AI intelligence, the brain, vision, language, or thinking and learning component, are too complex, and you need a team of data scientists to actually build those in. Thanks to the advances that we've all seen this morning, we've seen lots of demonstrations on how easy some of these tools are to use, thanks to things like transfer learning, which I'll talk to more in a second, as well as automated machine learning. These two concepts here, in my mind, are what bring about a big opportunity for AI projects to no longer be on the backlog, because you don't need a team of data scientists to implement artificial intelligence. You just need someone who's maybe got a Bachelor of Engineering and they have been trained in a specific cloud platform. So on the traditional deep learning versus transfer learning, when we looked at GPT-3, you can see that there's been a lot of time and effort from data scientists all around the world creating this GPT-3 model and contributing, improving. And they would have trained that data set on a massive test set. So I think it was Wikipedia. Wikipedia, I think, that's massive, right? So once you've trained that brain and it understands what all that information is, it's got a foundation that you can build from. So leveraging this concept called transfer learning, you can then provide it with a very small data set, and then it's almost like you've onboarded a colleague who maybe used to work somewhere else, and then you say to them, hey, can you just read over these documents, and this is how we do it? No worries. Now they know how to do that. And transfer learning, you can conceptualize it as being very similar to that. So just quickly on the RPA and AI market, you can see here that there's massive growth, exponential growth in both the RPA and the AI market. By 2030, we can expect $30 billion market cap for the RPA market. And for the AI market, by 2030, 38% increase, which is at 1.811 billion. So anyway, big numbers, you can see. There's big growth there, but I think what's really interesting to look at is within the comparison to other sectors, you can see the legal sector, it's got a footprint when it comes to the AI market cap. Okay? When it comes to robotic process automation, legal sector falls into the other category. So that's something to keep in mind. What I think we can learn from this is the reason for it is relative to banking, financial services, and insurance, or telecommunications. They're very high transactional industries. And remember, robotic process automation can be used to automate unintelligent tasks, meaning they're rules-based, if this, then that type scenarios. Okay? But within the law sector, there's lots of inferential decision-making, which can get complex, and it's not always a hard, fast rule. It's often a debate. So law, it's all about debate. Correct me if I'm wrong, I'm not a lawyer, but I'm pretty sure. So because of that inferential decision-making, that's where the AI component comes in. Okay, we're now going to get stuck into some hypothetical use cases. I do want to emphasize that these are hypothetical. Hypothetical being that there's a company A, and there's a description of what that company is, how many employees they have, and then the business process they have. And there's some estimates as well on how long it takes for them to perform certain tasks. And then we talk about the opportunity there, and then the solution, so potential ROI if you implemented a solution. So the first one we see here is templated letters of advice. What this business process is all about is essentially the company has a number of different templated letters of advice that their staff members use to send out to clients whenever that's required. So the business process is client X needs a templated letter of advice to be sent out. The staff remembers that the templated letter of advice needs to be sent out. Remember, these are templated, so that you can predict when they'll need to be sent out, maybe at the start of the case or the mid-case or towards the end. And then the staff would generate that templated letter of advice using the template again, and then send that out to the client. So if we assume assuming company A has 100 staff members, each staff member spends about 5 hours per week on this task, and then you can see how often they work and how much they get paid an hour. So if you just do those calculations, you can see that's $960,000 worth of opportunity costs in terms of effort for a business over a year. Okay. These figures will all be available via download, by the way, if you want to validate them. The solution that we can look at when looking to use robotic process automation, because that's all that would be required here, is a letter needs to be sent out. Okay? The solution would identify that a letter needs to be sent out. It would generate that letter based on the rules that were provided. Letters need to be sent out at this time, or these types of letters need to be sent out at this time. The template is available here. So be able to generate that. And there's a requirement to have a human-in-the-loop component here, because robotic process automation can generate that. It's probably going to get it correct, assumably 95% of the time. But every now and then, there's going to be an issue. And so you want to, and this is important because it's going directly to your clients. So you don't want to have any mix-ups with letters being sent out to your clients. So there's a review step here. And then once that's approved, the automation solution would know that, and then it would be able to get sent out. So to build a solution like this, based on, at Cognitive Automation Labs, the work that we've done previously, you look at about $45,000 to build this solution and then deploy it to production. There would be 2 weeks' effort required from one of the internal staff members from company A, because we need to work with them on what that business process is to design it. And then you can expect roughly a 5% failure rate here. So maybe the application that we're getting the client information from, the case management system, doesn't have, or there's issues with that system, so then there'll be failures there. There's some operational costs as well here, and then ongoing operational costs as well here. And so if you add that up, over a 2-year period, you're looking at $1.4 million in return on investment. And the payback period would be within 3 to 6 months as well. Time. Cool. So filing client documents. Across all industries, we see this as being a very common use case for both robotic process automation and AI. You'd need both of those. Not always. Sometimes you just need RPA, but sometimes you need both technologies. So the use case here is essentially documents get sent from various sources, and then we want those documents to be added to our legal case management system for record keeping and compliance purposes. Business process is document is received via email, presumably. Staff then reviews that document, figures out who it belongs to and what they need to do with it. They will then save that document in the internal case management system, and then update the key fields within the internal case management system that are relevant. So again, same number of staff members. There's roughly 25 clients per year that company A processes, and there's roughly 100 documents received per year per client from various sources. And it takes 5 minutes to file each document and extract the information, so complete the process. So for this business process, if you were to automate the entire thing, you'd be looking at about $833,000 is if you could automate the whole thing. But that, in our mind, you wouldn't automate the whole thing. Reason for that is whenever there's AI in the loop, this number here, number of scenarios expected to fail, is going to increase. Because there's inferential decision making there. It's not yes, no, the AI solution will output a confidence number saying I'm 80% sure this is what it is. But if you look at the solution here, document receive, the solution would use computer vision to review the document and extract information from it and identify what document it is. And then it can use robotic process automation to save the document in the system. And then using the computer vision information that's already been extracted in step 2, we would then update the key fields in the case management system via using robotic process automation. So a solution like this, it has robotic process automation and artificial intelligence built into it. It's more complexity, it's going to cost more, obviously. But you're also looking at about a 4 weeks effort from an internal staff member to assist with building that solution. Reason for that is we're going to need to work with them to identify appropriate data sets and then feed that into the model, and there'll also be training around training that SME once the solution is deployed. If you ever need to retrain it, how do you do that? And the business user would be able to do that moving forward. And you'll see how that is in the demo component. The annual RPA solution cost would be roughly this. This is both infrastructure and licensing, and then the annual AI solution cost would be about this. This is retraining your model as well as calling transactions to identify what the document information is. And yeah, the return on investment over a 2-year period is about 1.3 million. And again, a payback period would be about within 3 to 6 months. Good. So summarizing documents. Now, let's assume that company A has already built the second use case. And so they've already got a solution that can ingest documents, and it does some things with it. But we now want to add an element to it where it can summarize the documents as well, using some of the summary tools, GPT-3, that were presented earlier, for example. Business process is very similar to the other process as well, except the third step there is we're summarizing the document, and then the fourth step is we're adding the summary to some type of system, or maybe you just want to drop it in Excel, whatever the business process is. If we look at the figures here, very similar to the previous example, except it takes roughly 8 minutes for each document to be summarized, and all the other figures are the same. So for this use case, the opportunity here, if you were to automate it, would be 1.3 million savings per year. But again, there's the artificial intelligence elements here. So there's inferential decision making, okay? And so again, there's that 20% scenarios are expected to fail because of that inferential decision making component. So you can't automate all of it, is what I'm saying. But the document would be received, the solution extracts document text using artificial intelligence, computer vision, and then the solution would summarize the document using the language element of the AI brain, so to process that information and create a summary, and then the solution would update the summary into the system for that specific document. That would use robotic process automation. So as I mentioned, company A already has, assumably, the previous solution implemented. We're mainly implementing the AI components to this. There's a little bit of RPA, but we would expect most of it to be built from the second solution. So you can see what the expected price would be for that. And everything else is the same. So you can see here that the return on investment for a solution like this would be $2 million over a 2-year period, and a payback period between 3 to 6 months. So I wanted to get these use cases in front of you guys so you could see how would this actually work in terms of improving a business? So this is not from an academic perspective. There's different use cases for that. This is more so improving potentially the operations of your legal practice, or potentially even the university. They often use these two technologies as well. But with that in mind, we can now get stuck into some demos. So before we saw an example of the first one, the first use case, whereby the solution would need to use robotic process automation, and it would do a number of things using the arms and legs, or the execution part of automating knowledge work. So what we'll do here is I actually created this solution. It took me 2 to 3 hours to build this solution. Again, this is demonstrating the ease of use of some of these tools. And the tool I chose to use was the tool that's actually business friendly. So if you're a business user, you can download this tool. You can try to build something yourself. And then it also has a mechanism where you press a button, it converts it to code, so you can give it to a more technical person like myself. So let's hook in. Now, this is the solution here. Just going back to this demo, what we're going to do is we're going to press run, and what it's going to do is it's going to go to the Queensland Case Law website and download a bunch of QCAT case law PDF files, and then it's going to save that in my local drive. So this could be an example of something that we would use to extract information that we can feed into potentially a machine learning solution, or an AI solution, sorry. So we're collecting training data, for example. So with that in mind, I'll hit run here. I'm going to move the screen around a bit, and then I'll do hands off. Live demos are always a little bit risky. Yeah. I tried recording this last night, this bit, but the bot performed really slowly, so because of the recording software. Okay, so we can see it's fired up. What it actually did there is it launched a container in the background, so it's containerized infrastructure for those who are into that technical stuff. And now it's navigated to the page we want it at. And what you can see here is it's navigated to this page. It's filtered, I want to show me 25 results. Okay? And now the solution is looping through. It's designed so that for each page, it'll loop through and download as per the number of results that are on this page. Okay, so that's done. We only downloaded 3 because I didn't want this presentation to be the whole session. This demo, sorry, to be the whole session. But if we come here, so you can see that within this file here, there's 3 examples that I've downloaded, right? Within this file here, you can see there's a whole lot more. In fact, I think there's about 10,000 files. And the reason for that is that on the case law Queensland site, that's how many QCAT examples there was. So I decided, hey, I'm just going to run this thing, and I'll try to feed it into an AI model for the demo. So that's an example of robotic process automation, how it kind of looks. And you can see how the agent component of robotic process automation is really, it's a robotic agent. So that's why it's robotic process automation, as opposed to just process automation, because there's that robotic element in it. And it can interact, because it's a robotic agent, it can interact with UI screens and do different things, as well as using APIs. Great. So now that we've got an idea of how robotic process automation works, by the way, the tool used for that was Robocorp Automation Studio, free for download. And you'll have access to all these links and stuff at the end of my presentation, so you'll be able to access that. This demonstration here is a demonstration on extracting key information from case law documents. So we already showed a solution that could download a bunch of case law documents. That's awesome. And we've got all these case law documents. What do we want to do with them? So potentially, we want to extract the key information and then categorize each of the different documents into different matters. And then potentially, maybe we want to summarize the orders made or something like that. So similar to that use case 2, where there was a component where you needed to extract key information, this is an example of a technology you could use to do that. The technology I'm demonstrating here is Azure Form Recognizer. So Azure Form Recognizer, in order to get started with this, you do need an Azure tenant subscription where, yeah, it's not that hard to set up, but you do need to configure a credit card. But if it's the first time signing up, you can get a free $200 free for a month or something, so for 1 month. So you can explore with this. So what I've created here is I've created a model of a base model, and using the Azure Form Recognizer Studio tool, what you can do is you can create a new model. In fact, let me. Good for time. So with Azure Form Recognizer, you can see here that they've got a number of different pre-built models. Okay? And we saw before that there's a lot of pre-built models for natural language processing. So AI Brain, there's a language component, and we've seen a lot of models for that. So that's really good. This Azure Form Recognizer, you can view this as almost being the vision component of the AI Brain. And you can see there's a lot of pre-built models here that you can use for different use cases. Really good if they're invoices, receipts. These won't work though if you're looking to extract key information from case law documents, fortunately. No worries, we can create a custom model. So go through that process and you'll eventually get to this state here. Okay, and you'll need to upload a number of different examples that you want to use to train the new model, okay? And all you do is you just define different regions, okay? For example, parties. Let's call this parties field, okay? And so there's this parties field. So and you can see that we've done something very similar for all of these. Okay, I'm just going to get rid of this though, we don't want this. So when we've mapped out all these different regions, we've essentially trained this model. We're about to train it. You can see the train button here. We've essentially trained this model so that it knows for these different documents where are those key fields and that key information. I'm going to hit train. It's already trained anyway, so v0.3.0. The neural approach worked better last time. Okay, so I expect by the end of this presentation that model that we've just built would be completed. It takes about 5 minutes. But for the demonstration, what we'll do is we will look at this pre-built model here. Test. Cool. And like I showed you before, we've got these different labels configured, okay, for all these different solutions. And you can see there's only 8 to 10 examples here, right? So with 8 to 10 examples and then retraining, let's see what output we get. Analyze. And you can see before this is case 2, which wasn't in the previous one. Previous one was case 1, 10, 11, 12, 13, 14, 18, I believe. Okay, and so we spoke before about a concept of transfer learning. Deep learning versus transfer learning. And what this is transfer learning in action. Okay? You saw before there was a bunch of pre-built models that you could use, and you can use those foundational models just by default, and they work pretty good. But for specific use cases like this, and especially when it comes to the vision component, often the vision components require some retraining, and this is the result of that. You can see here with this example that if you were to work with a vendor to then build the solution, okay, and then new documents started coming in, but that vendor had rolled off, but you need to update the solution so it can use those, it knows those new documents, structure, okay? You can see that by this interface, how easy it is to label, okay, and then train. Any illegal practitioner would be able to do this. I mean, maybe not anyone, but you know, I'm going to say a high percentage anyway. But what I'm saying is you don't need to have an implementation partner there all the time to do something like this. You could build the skills internally without a whole lot of effort. Okay. So Now, the other demo I had, it was on GPT-3, and I don't think there's a need to go over it because we've already touched on that a lot. So, yeah.
Yeah, one question.
Yep.
Thanks. I was just feeling very amused because I used to work in the courts, and trying to get all the information in the right place was a fight we had to have for a while. And also summarising the judgments was one of my first jobs when I went to the court. So having something like that to put the judgment in and get a summary would have saved me a heap of time. My question is, that's awesome, and I guess as a law firm you could, is it possible to get cases come in, and I imagine something like this could analyse them for you and help you keep abreast of new decisions coming through. So if you had an intellectual property practice, for example, you could bring those in and analyse the information that's in there and feed that out to your various practitioners in the firm.
So what that would all be about is you'd have to design out what that would look like. But just off the top of my head, a design like that could be every week have an RPA solution that logs in, downloads information relative to this, and then update the model accordingly.
Great, thank you.
Cool. Yeah, thanks, guys. If you want to download link for the presentation here, this is the QR code for it. And yeah, feel free to reach out. If any questions, you can do that via the contact form here as well.
Thanks very much, Tyler.